an
This
80
conference will
A04.
now be recorded.
So we did take a look at what are the segments of an ADT A04 message. We started taking a look at message segment and what are the essential fields of that element which we usually use. And we saw that there are a few fields which we need to be aware of. So I highlighted them in green. Let's continue taking a look at further other segments which are important as part of an ADT A04 message. So when you look at an ADT A04 message after an MSH segment, we might see that we will have an EVN segment based on the version. So EVN segment will indicate an event. Apparently, these two values that we are seeing here might be present in the existing MSH segment. But if EVN segment is present, you might be seeing these two values in there. So those are nothing but the event type code, which we transact in MSH 9.2. The event type A04, A08, A28, or S12, S13, S12, S14, S15, and so on. So whatever the event of that message is will be sent in EVN1 as well. And then EVN2, which is message generation or recorded date time, which is again same like a message 7, where we generate the date and time of the message. Then you have PID segment. So in PID segment is the segment which will indicate the patient identification information. So most of the fields are pretty much straightforward. So we'll quickly run over it, but we'll talk or emphasize a little bit on few of the fields here as and when we go ahead. So if you can see here, we have PID1 is a set ID. Set ID is present not only in PID segment but in also many other segments. This usually indicates the sequence number of that particular segment. So let us say we have multiple segments of the same kind. For example, there are multiple PID segments in the HL7 message, or there are multiple OBR segments in the HL7 message, or multiple OBX segments. Each of these segments have set IDs, and these set IDs will have a sequence number. That sequence number is represented in PID, the first field usually. So similarly, PID has set ID. If it is just one segment that we have, then we'll have just one as in set ID. But if we have repeated segments, then there will be a sequence number associated with the set ID. Then you have PID2, PID3, PID4. These three fields indicate the patient identifiers. So now you might be wondering, why do we need so many fields for patient identification? Apparently before version 2.7, we used to have PID2, PID3, PID4, but 2 and 4 are withdrawn after 2.5, and everything has been moved to PID3. But where do we see, or how do we see different patient IDs being present there? So if you look at the hospital system, usually hospital will have an internally generated patient ID or an MRN number which is being assigned by the hospital itself. So these are the two different kinds of IDs which you usually come across when we are dealing with any hospital system. If that PM system is integrating with some other PM system or some other registration system altogether, then the PM system might also store that another PM system's ID as well, which where we might end up in having another patient ID. So based on the workflow, based on the scenario, you might end up in having more than one patient identifier for one single patient. It could be of a different system or it could be of an EMPI system. So it absolutely depends on the scenario, and having multiple IDs for a single patient is possible. So to communicate all the IDs, we have accommodated that through PID2, PID3, and PID4. But after the release of version 2.7, we saw that uh, PID2 and PID4 are deprecated, meaning they are not being used anymore. They should not be used after 2.7 version, 2.5 version, and everything has been moved to PID3. So what do I mean by moving the information to PID3? And we see that it is a repetitive field. So let's go ahead and take a look at an example to understand what did it mean to go ahead and change that to PID3. So if you look at this PID segment, we see that in MSH2 there is patient ID. 4 is blank right now, so we'll leave it. MSH2 has the patient ID. MSH3 has repeated IDs present within the field. So let's talk a little bit about repetitions, then we can focus on what are the different IDs that we have. So let's say we have two different IDs, one is MRN number, the other one is system generated ID. Now instead of having just one ID in field, let's say this is the only ID that we have in the PM system. There is only one ID in the HL7 message, but PM system has one more than one ID. So in that case, we can use this repetitive field or repetitive or delimiter, which is called as tilde or an inverted S, and then you can use your secondary ID, which was there. So what does this repetition indicates is it will just add a virtual pipe to your um, just assume that it doesn't mean that this is how it is represented. When you have a repetitive symbol, it indicates as this is PID3 and this is also a PID3 and both are repetitions. Okay, so this is called as PID3 repetition number 1. This is called as PID3 repetition number 2. And you can have any number of repetitions as you want. There is no limitation that you should have only one or two or three repetitions. That is what this is being indicated here. So when the repetition number is infinite or mentioned as star, it means that there is no limitation on how many number of IDs you are transacting for uh, in place of a patient ID. So if you have many, then you can transact all of them in PID3, and PID2 and 4 are deprecated and not being used anymore. Okay, so how do we navigate through an HL7 massive and PID segments or any field has repetitions? So we call out the segment name and then we call out the field number, and then we use 3.1, 3.2, 3.23, 3.4 and so on. So we use the normal navigating mechanism. But we add one more thing at the end. We call it as repetition number 1, repetition number 2, repetition number 3, and so on. So when we want to specifically talk about or specifically deal with one of these repetitions, then we would say, I would like to take a look at what is present in PID 5, PID 3.1 for repetition number 1 or repetition number 2. So you specifically mention the repetition number so that we would know which repetition we are going to talk about. Everything that is present will be read as PID3 only. Okay, all the three will be read as PID3, repetition number 1, PID3 repetition number 2, PID3 repetition number 3, and so on. So next we have PID5, which is patient name. So here we indicate the name of the patient, which we know that we will have last name, first name, middle initial, and there are many other things as part of the name. So you might be also seeing suffix, prefix like senior, junior, or doctor, something of that sort. So that will also be present in PID 5. Next we have PID 7, which is date of birth. Uh, so that will indicate date and time of the birth of the patient, and PID 8 indicates gender. So if you look at this one, gender is associated with the table. So when we click on that, it will take you to this website. So as I said yesterday, gender is a user-defined table. So if it is a user-defined table, then HL7 might or might not suggest few values. So here HL7 is suggesting these values, but it is up to you. There is no compulsion on using this one. If you want, you can use it, or else you can have your own definitions of what are the values that you want to use and what are the descriptions that you want to use, and you can add your own code set mapping. So code set mapping, in the sense, you can have your own descriptions and values that you want to use in the real-time implementation. Then you have patient race information being sent in PID 10. Again, this is also a user-defined table where user can pick up the information from. And PID 15 is your language. So patient's language is being sent in PID 15. So the patient might know multiple languages, but only the primary language is communicated in PID 15. Next, you have PID 16, which is marital status. So again, this is also a user-defined table. And then you have PID 19, which is SSN number. So as of now, that is being withdrawn from version 2, from version 2.7. And then you have PID 22, which is ethnic group. So if you want to communicate about ethnic group, that can be sent in. I mean, if you capture that in the front end, then that will be sent in PID 22. You might be seeing that there are many other fields as part of PID segment, but um as I said in the beginning, when we were talking about HL7, HL7 has been designed from a perspective to include all the fields that could be possible in the whole world out there. But it doesn't mean that we need to use each and every field. Based on what we capture in the front end and what the application can accommodate, uh, only that information can be transacted within the HL7 message, right? So these are the most common fields. Whatever we just saw are the most common fields that we usually capture in the front end systems and can transact in the HL7 messages. So then you have PID 29 and PID 30, which is patient death date and time and patient death indicator. So this is a Boolean value which indicates just yes or no. And then you have if patient is deceased, then you have his death date and time updated, so that downline systems, whoever is receiving the information, can have the updated information regarding the patient. Next, you have patient visit segment. So before taking a look at visit segment, let's quickly see how our smart viewer shows repetitions for patient. So let me go ahead and load this. All right, so now we have repetitions in PID 3, right? So the moment we click on that, it will show what are the components of each of those PID3 repetitions. First, if repetitions are there, immediately you have to look into the bottom section where it will show you the repetitions that are available. So you can see that this is repetition number 1, repetition number 2, repetition number 3. And when you highlight on each one of them individually, it will show you the individual components of that specific repetition here on the right hand side. And if there are sub components present, it will show up here. So now let us talk about patient visit segment. So patient visit segment has a certain significance from demographic perspective as well as from HL7 demographic perspective as well as from appointment perspective. So the data that will be transacted when a demographic message sends a PV1 is little different from what is being sent in appointment related message. We'll talk more about that when we get to the appointment message. We'll just have a quick comparison of what is the significance of PV1 segment from a demographic perspective, and also we'll talk about it from appointment perspective at that point of time. For now, we'll talk its importance from demographic perspective. So PV11 is set ID. Again, if you are having a repeated segment, then you will have more number of segments, and each of them will have a sequence ID in PV11, the set ID information. Then you have PV12, which is patient class. So this indicates whether a patient is a an inpatient or an outpatient or an emergency patient. So what kind of patient that we are dealing with, that will be indicated in PV12. So this will also be captured in the front end and will be communicated in PV1 system, PV1 segment. Then you have assigned patient location. So this field is also very, very important because whenever a patient is registered, let's say there is a hospital which has multiple branches all over the city, and patient might be visiting one of the location. And when he gets registered, his location information will also be captured to figure out where he got registered for the first time exactly. All the hospitals throughout the city might be using the same system or uh, yeah, same system and same clinical system. And capturing location information will give more information to doctors and to the staff on where did the patient come from. So that information will be captured while registering the patient itself. If the provision is provided within the software systems, usually they do. Usually patient information, location information will be asked and updated in the PM systems when they capture the demographic details. Then you have a PV17, which is attending doctor, nothing but patient's primary care provider, whoever or usual provider, whoever is the patient's immediate family doctor kind of thing. That information will be sent in PV17. PV18 is the referring doctor. So in case if patient is visiting a huge hospital and if he has been referred by someone else to that particular hospital, then that referring provider information will be sent in PV18. Then we have PV119, PV144, 45, and 50. These are uh, the fields that we have to look from appointment related messages or appointment perspective. So we'll take a look at them later, and we'll figure out, we'll try to understand what is the significance of those fields are. Next, we will jump on to the guarantor segment. So what is a guarantor segment in the US, or apparently uh, in most of the countries? Usually you will have a guarantor where they will assure that they will pay the bill, or bill will be taken care by them or their insurances. So guarantor information will also be captured while the patient is being registered so that they can be rest assured who will be taking care of the responsibility of insurances or bills. Now, this plays a major role when we get to the family billing concept. If the patient himself is the guarantor, then that's not a problem. For example, I am visiting the hospital and I have an insurance on my name. And once I go, I'll say I'll provide all of my demographic details and all. And then I would say I'm the guarantor myself because I have my own insurance. Now, that is an individual billing concept. But what if we have a patient family billing concept where I might have my children, and my children are being taken to the hospital for some problem. And when my child is the child will be registered as the actual patient, so patient demographic details will be my child's information, and then the guarantor information will be my information. So they will separately register guarantor related details and then update their systems to make sure guarantor shows up as my name, and insurance will also be on. I mean, as it is a family insurance, it I'll be the main subscriber of that insurance, so insurance will also be on my name. Apparently, child will have a subscription to that as well, as he is part of the family. So in such cases, you'll be seeing PID related information is a little different from what we see in GT1 segment. So if it is a family billing. So this scenario could apply for children, spouse, uh, based on the insurance plan. So if you look at the fields of guarantor segments, these will be pretty much equal or same to what you see in PID segment. So you'll have set ID, you'll have guarantor number, guarantor name, phone number in GT16 and GT17, and then you have GT18, GT19, where you have the gender. One quick thing that I wanted to highlight about PID segment, I think I forgot to highlight that. So you might be seeing that in PID 13 we have phone number. Again, phone numbers are repetitive fields here. So you can send both the phone numbers or as many number of phone numbers that you have as a repetition in PID 13. So as you can see here, you have repetition number 1, PA, repetition number 2, repetition number 3. And if you have more number of phone numbers, then they can be communicated further on these fields, in these fields basically. So let's go back to the guarantor field. So in guarantor, as I said, most of the fields represent the same as like a PID segment because we are kind of capturing demographic details of the guarantor. The important field here is GT111, GT113, 14, 24, and 25. The reason why they are important is it will indicate what is the relationship between the patient and the guarantor. So you have list of values where you'll be where HL7 has provided few suggestions, but it is a user-defined table, as I said. You can go ahead and have any values as per your need. But apparently, we see that it could be brother, caregiver, child, guardian, or someone who can be the guarantor for the patient, indicating that I'll go ahead and take the responsibility of paying the bill. It's not just that family billing. I just took that scenario so that we can understand it better. But if someone else is promising on behalf of us that they will pay the bill, then they will become the guarantor. And then the relationship between that guarantor and the patient will be specified in GT111. So they do really capture that information in the front end in the PM applications or the registration modules on what is the relationship between them. Then you have GT113, which is guarantor start date and end date. So let's say I have visited a place and my uncle there, it happened to happen something there to me, and my uncle becomes the guarantor there, and he'll be the guarantor only for those 2 or 3 days of time when I'm staying there. So guarantor start date and end date is also important, and this is also usually captured in the front end systems. And then you have guarantor disease date and time and their disease death flag so that the downline systems could know that this person is no longer the guarantor for that patient. So they will have that information very clearly indicated in their systems. So next we'll talk about IN1 segment. So insurance segment is another important segment as part of a patient demographic system. So if insurance is captured, it is not always the case that everyone will have an insurance, right? You might see that patients might have cash as the payment mode, without being insurance in play. So if insurance is present, then it is sent. IN11 indicates the set ID. So if patient has more than one insurance, then that will be indicated or captured within the PM system. Usually three insurances are uh, allowed. I mean, allowed in the sense when you look at the PM softwares or registration modules, you'll have placeholders to store primary insurance, secondary insurance, and tertiary insurance. All the three insurances can be stored in the software systems. If more than one are present, then set ID will indicate the sequence number 1, 2, 3, and so on based on the number of insurances that are present. Then you have IN12, which is health plan ID. Again, this will indicate what kind of health plan you are in. Based on the insurance plan, uh, that plan's ID will be sent over in IN12. For example, if you're going for family billing, that family billing might have a specific ID from that insurance company's perspective. So that health plan ID will be sent in IN12. IN1, 3, 4, and 5 indicate what is the insurance company ID, insurance company name, and and their insurance company's address information. So this is usually picked up from the library that is present within the PM systems. So it would be like, let's say PM system, when you're setting up the PM system for the first time, let's assume that we are setting up the PM system for the first time. So when we do that, we load few things predefined, or we load few libraries like CPT library, ICD library, and at the same time we also upload the insurance library. And when we upload the insurance library, we'll have all the insurance companies in that specific area, and we'll also have its company information, address information, and all. So this information will also be communicated within the HL7 message. Next, you have IN18 and IN19, group name and group number. So we know that uh, usually there are many different groups of insurances that will be there. So that group name and group number will be present in IN18 and IN19. And then you have IN112 and 13, insurance plans effective date and time and expiration date and time. Very, very important. And usually in the front end systems, whenever an insurance is expired or is about to expire, then when the patient arrives at the hospital, they'll get a notification, or as soon as they pull out the record, they will see a banner at the top stating that patient's insurance is expired or completed or about to expire and so on. So that hospital staff or the patient or the clinical staff have some sort of confirmation on what will be the billing process post the visit. Then you have IN115, which is plan type. So this will indicate whether something is a Medicaid plan or a Medicare plan or a Blue Cross Blue Shield plan. What kind of plan that we are dealing with will be indicated in IN115. Then you have IN117, which is insured's relationship to patient. Again, this also represents or relates back to whatever we have seen in guarantor segments, patient relationship with guarantor. So similar in the same case with the same case that we have seen where we have father-child relationship. So father is the actual person who has the insurance, but child is becoming the patient here. So in such cases, a relationship between the child and the father will be mentioned, and that will be sent in IN117. Then you have insured's date of birth and insured's address. So that information will also be sent in IN118 and 19. Next, you have IN136 where you send the policy number. So each and every policy will have a unique policy number that will be communicated in IN136. IN114, this will indicate coverage type. So this usually indicates the information about whether it is a whether the insurance covers the hospital charges or just the physician charges, or whether it will cover both the charges. So that information will be communicated in coverage type. Okay, so So those are the few important fields of IN1 segment. So now we have seen so far about what are the important fields of an ADTA04 message. So we have MSH, EV, and PID, and then PU1, GT1, and IN1. So you can use this sample example to go ahead and review what is the how does the record look like. So now that we understood what is this importance of, or what is the what are the various fields that are part of an ADT message, we also need to keep in mind how the demographics information is exported or imported into the system. What is the mechanism that we use? So understanding that is also very, very important as an interface analyst. It seems to be very easy just by looking at the data that we can go ahead and just pick it up and get that inserted into the database and all. But in real time, it doesn't work that way. Always remember, exporting the data from system is far better, not far better, and from complication perspective, it is far easier than when you import the data into the system. And why would I say that? Exporting the data is kind of you just extract the data on whatever you have within your system and then convert it into HL7 message and send it over. It's the responsibility of the receiving system, which where they have to ensure that lot of things will be taken care before importing that received data into their system. We'll talk about that. First, we'll close exporting, and then we'll see what we have to do if we are a system of importing. Uh, so when you export the data, let's say you are working on a PM system and you have to send out all the demographic events to the destination systems. Then you access your PM database. So as I told you the other day, each and every application has two entities, front end and the back end. Front end represents the application that you're seeing, the good look and feel of the application, using which you will be saving the data. And the back end is nothing but the database where the exact information is stored. It is not always essential that it should be a SQL database. It could be a NoSQL database as well. But for now, we'll restrict to one of the SQL databases. So we have the backend database, and within that database, we have tables which are actually storing this patient demographic information. So whenever you save any patient details, there will be a table called as patients, which will actually store the information for us. Let me quickly show you about how it looks like in the database. So this is a sample database that I created for the purpose of training, and it has various kinds of information in there, and we'll be using this. I'll be sharing with you in the future so that we can use this and extract data and generate HL7 messages or interpret data and insert data into the system and so on. So if you look at this particular database, there is one table called as patient demographics. So whenever there is any uh, let me run this. So whenever there is any patient who gets registered, the entire patient information will be saved in these tables. So as soon as this is saved, we will be going ahead and as interface analyst, we'll pick up this information and generate PID segments, IN1 segments, guarantor segments, and so on. Right now here we are just seeing one of the one of the demographic tables, but we'll have individual tables for guarantors. If you can see here, we'll have insurances, and we will formulate our query in such a way that we are picking up or extracting data for all of the essential data fields, and then we'll generate the HL7 message and send it over. Once we extract everything, once we are sure that we are extracting all the required fields, next step we'll create an HL7 message or construct an HL7 message and send it over. So that sounds pretty easy. I mean, not much complicated. If you're aware of SQL, if you're aware of the integration engine mapping rules and how do you achieve that, it's easy. It's not very difficult task. Complication comes into play when you actually import the data into the system. Okay, let's see why. Let's say patient is arriving at the front end. He's visiting hospital for the first time. He has been he hasn't been there before, and he will provide his demographic details. Everything will be registered, and as soon as patient is saved, a new row is formed in the patient demographic table. Okay, and as soon as that is done, the system will generate an ADT-A04 message, will generate the PIDs, GT1, IN1 segments, and everything that are needed, and it will send out or export the data into data to the EHR system. Now let us assume that we are EHR system. Okay, PM has sent its message. PM's work is done. EHR, when receiving the message, it needs to validate whether that patient record is present in the system already or not. If it is present, then it has to update the existing data. If it is not, then it has to go ahead and create a new patient record altogether. So this is where little bit complication comes into play, because we should be very careful, and our store procedures should support validating whether that patient is already present in the system or not. How can we achieve that? How can we know that whether the patient is already present in the system or not? So to achieve that, there are various ways or various logics that people follow. So one of them is just looking at the patient ID, um, let's say PID 3.1. So they will just cross map it with PID 3. So if PID 3, which is patient ID value, is already present in the database, then the systems would consider it as an existing patient record, and it will go ahead and update the details of that record which was already there in the system. So let us see what happens in that scenario. Patient gets registered for the first time. An ADT-A04 message will be received on the EHR side. As patient is visiting for the first time, they will register all the details, and everything will be registered in the EHR system. Registered in the sense, the demographic message that is received will be imported into the EHR system, and patient record will be saved. Now the second scenario, where patient is already been to the hospital earlier, and he is updating just his address information this time. Okay, and when his address information is updated, it will trigger an AT-A08 or A31 message, right? And that message will travel to EHR. EHR will again start its process. It will try to pull out the patient ID and see whether that patient ID is already available in the system. As patient information was already registered, this ID will be available. So whatever changes were done and has been communicated through HL7 message will be updated in the EHR systems for that specific patient ID where it found a match. Okay, this is based on patient ID. What if we are dealing with a system, or what if we have a scenario like this, which is pretty much possible? Let me pull out something. So let me pull out a notepad. So let us say there is a centralized EHR repository which is actually storing the entire patient demographic information. Oh, sorry, patient clinical data. And this hospital has multiple locations. One of the and multiple locations in all over the city, and small clinics. Let's say we have one small clinic where patient demographic can also be stored, and we also have a larger hospital or a different branch altogether. Patient can be registered anywhere, and information can be sent over to the EHR system. So in this case, as this is PM1, and you can say that this is PM2. So in this scenario, what happens? The PM will send out information to EHR. This will have a different patient ID, And if the same patient is visiting the second hospital or second main branch, he might be registered there as well, and he will have a different patient ID here. So if same patient is visiting both the places, the IDs would differ because the software systems are different altogether, unless they are maintaining single MRN number across the board. So this will create a problem if we use just the patient ID as the matching criteria to figure out whether the patient is existing or non-existing in the EHR database. So we need to be very careful in choosing the mechanism of what should be the patient match based on. So in case if you have scenario of this kind, it doesn't provide you any solution, right? Because PM1 will register the patient. It will have an ID of, let's say, 123. Okay, and patient visits the second hospital. He will have an idea of ABC in the second hospital. So when the information travels from here to here, patient will be registered. He will have a record for 123 in the EHR system. Now the same patient is visiting the second hospital, and he will have information sent from second PM to the system, and the same patient will have secondary chart in the EHR system for the second patient record. Apparently, these two are same records which should be together, but we'll end up in having duplicate records or duplicate charts is what we call in the EHR system, which is not acceptable. Okay, so to avoid these kind of scenarios, they will eliminate using PID, patient ID information. They will be using something called a scorecard match. Okay, what do I mean by scorecard match? So what they will do is they will assign certain weightage to most important demographic fields, and then when all let me put it this way. So they will assign few points to each of the important demographic fields, and when all of these points are added, it should reach a certain threshold limit to say that yes, this patient is an existing patient record. Let's see how that works. So let's first figure out what are the important fields. So let's say we have patient ID, we have patient name that will be considered, and it will have last name, patient first name, patient DOB, patient gender, and some other identifier like SSN. Okay, let's say ID has 20 points, 15 points, 15 points, 10 points, 5 points, and another 15 points. Okay, so let us assume that each of these fields or each of these data elements have been given certain weightage, certain points. Okay, now as we know that patient IDs wouldn't match, let's say we are receiving these two records that I said. Okay, one is having patient ID of 123 and the other one is having patient ID of ABC. That wouldn't match, right? Now patient name, let's say Dixon is the patient, and when he receives for the second time, all right, let's first register the primary details. Okay, so patient has visited, patient last name, first name is Dixon, last name is Tests, and then he has his date of birth as 1/1/1995, and then you have your gender information, and then you have your SSN number, some sort of number, some number. Okay, now the patient got registered in the first PM system that we saw. Okay, If they use the patient ID information to register the patient, obviously a new record will be created because system wouldn't know that the patient information is already present in the system. So we wouldn't use that. Instead, we'll go ahead and use some other information like first name, last name, date of birth, gender, SSN to determine whether the patient already exists in the system. So let us see what happens in the real time. So now when the interface receives a demographic message from the second PM system, which is this one, it will receive the details of the patient. And when it receives the details of the patient, it will try to match all of these fields. So if it finds a match, first it will try to look for last name. And if it finds a match for last name, it will add 15 points to it. Okay. Then we have first name. If first name is matching, then it will accumulate another 15 points. Altogether, we arrived at 30 points right now. And if his date of birth is also matching, then you will see that it is adding 10 more points. Similarly with gender, and then similarly with SSN. So there will be a certain threshold within the PM interface, EHR interface system. It says that if accumulation of this point reaches 50 or 40, then I would say that it is an existing patient altogether. So let's say this is 10, and then we have gender as 5, and then we have SSN as 15. So this threshold will be decided by the programmers, whoever is designing the interface. So they will say that the threshold limit or the minimum score points to say that patient is already existing is 40. Let us assume that it's 40 or 45. Okay. So now we'll see the system will receive demographic information. So it matches first name, last, it will add 15 points, and it will add, it matches last name, sorry, first name, it will add another 50 points. Now it becomes 30. And then you have your date of birth. So it will add another 10. It will keep adding only if it is equal, right? So it will add another 10, it will become 40, and finally it will have gender, it becomes 50. SSN also matches, it becomes uh, 60 altogether, right? Am I right? Yeah, it will become 60. So the moment it crosses 45, then it is firmly assured that yes, this is an existing patient record, and it will go ahead and figure out for which record it is this criteria is met, and it will go ahead and update that specific record. So even if we don't have the unique identifier of patient, following this logic, it can find which is the exact patient match. Let's suppose that we are not receiving SSN in the second patient. Still we will reach the threshold of 45 points, right? So it will go ahead and update the information. So this will be written very logically to make sure that incorrect patient details doesn't get updated, and threshold will be set in such a way that most of the fields are matching, then only it will reach that certain threshold limit. Okay, so that is how a patient demographic matching happens in the EHR system, or in fact any system who is importing the data from other systems. So this is, we usually call it as linking logic, to make sure that linking happens perfectly fine, not just with demographic message. We can have the scenario with appointments, orders, uh, and results as well. So we'll be talking about individual events as and when we arrive at that point, and we'll be talking about these workflow mechanisms at that point as well. All right, so we'll conclude today's session here. I'll open up the forum for questions. So if you guys have any questions, you can just shoot them. All right, so I'm not hearing anything. So as we do not have any questions, we'll go ahead and conclude. So if you haven't enrolled, please talk to Srinivas and please get enrolled into the course. And once you are enrolled, you'll be given access to a Google Drive where we'll be having the recordings for on a daily basis. Just in case if you have missed the session, you can go through those recordings at any given point of time. We'll also have a WhatsApp group so that we can communicate with each other efficiently as and whenever we have a question. And we'll also, as I said, we'll also share the drive where we'll be uploading all of these documents that I'm sharing on the screen, the PPTs that we have seen yesterday.